Let me start the session, sir.
Okay, sir.
A very good afternoon, participants. I'd like to welcome all the participants for day 5, session 2 of AICTE sponsored 6 days online short term training program on emerging trends and research challenges in the next generation wireless network. Welcome you all. It's my pleasure to welcome our today's first person, Dr. Jonathan M. Cancino, Quality Assurance Head, Triple Section, University of Technology, Muscat. Welcome you, sir.
Thank you, sir.
Before going to session, let me see the short intro about our resource course. If your actions inspire others to dream more, learn more, do more, become more, you are a leader. I'm saying about the person who is none other than our today's show's person, Dr. Jonathan M. Cancino. He completed his Bachelor of Science in Electronics and Communication Engineering from University of St. Louis, Philippines, and completed his Master of Technology from Technological University of the Philippines, Manila, Philippines, at 2005, and completed his Doctor of Philosophy in Technology from Technological University of Philippines, Manila, Philippines, at 2012. He has more than 25 years of experiences in the teaching field in various responsibilities like Dean, Lecturer, and Network Administrator. His professional expertise like paused in the Professional Electronics Engineer License Examination last March 21, 2011, and paused the Electronics and Communication Engineer License Examination at November 1998. He also a technical trainer and consultant of a Prince Valiant Innovator from June 2007 to present. His professional qualification like a Cisco Certified Network Associate, Cisco Certified Network Professional, and Microsoft Certified Professional, Microsoft Office Specialist, Professional Electronics Engineer, and so on. He has various skills like computer repair and troubleshooting, networking, and programming, and so on. He has very much familiar in some of the courses like telecom networks, telecommunication, electrical circuits, computer networks, data communication, principle of communication, logic circuit and switching, engineering management, networking, visual basic programming, and office productivity tool, and so on. He acted as a chairperson, delivered special lectures in various conferences, workshops in various reputed institutions. In this way, now I would like to handle the session to our resource person, Dr. Jonathan M. Cancino, who is going to handle the session on the topic of LORAWAN and its applications. Please, sir.
Thank you so much, sir, for that generous introduction. Can you hear my voice clearly?
Yes, sir. Clear, sir.
Okay. So I'll begin to share my screen. I will just turn off my video to minimize the bandwidth and share my presentation. Share screen. For a while. Can we remove this part here? New slide. Okay. Is my slide visible, sir?
Yes, sir. Visible, sir.
Okay. So good morning once again to all the participants. I would like to acknowledge the patron, the chief organizer, and the Department of Electronics and Communication for such a wonderful training provided to our participants. So my topic this morning will be evolving on LORAWAN technology and its application. So to begin with, allow me first to, okay, why is my screen not moving? Okay, it's here. Yeah, a few of copyright disclaimer that this presentation might contain some information taken from books or references from other author or pictures taken from other resources. So fair use is a use permitted by a copyright statute that might otherwise be infringing. So non-profit educational or personal use tips the balance in favor of fair use. So all rights and credits go directly to its rightful owner. So I don't have any ownership of this presentation. Okay, this is just simply used for the purpose of teaching and research. So allow me to ask you first this question. How are you familiar with the IoT? We have heard IoT 1,000 times, 100 times, but how familiar are you? At what level you may consider yourself being a professional in this particular field? Some of you might say, I am an expert. That's good. Some may say, I am a beginner, which is fine. So let us see, according to A.T. Kearney, based on their studies, that there are only around 17% currently in the IT sectors, which is considered as expert. Almost half of the population are simply those who have knowledge through other people or might have read and some other resources. So generally, there is still a big market for people who want to work in the IoT sector. Okay, so it is very clear in this particular survey that only a few are still considered as expert. So now, if I may, let me ask you again this question. What is an IoT? Right? Each one of us may have its own interpretation, might have its own definition, but generally speaking, what is an IoT? So this definition will clearly address the question of what is an IoT. So IoT in general is just a network, okay? I would like to highlight the word, a network of physical objects. Objects that includes devices, vehicles, buildings, or any other embedded electronics. Now, since it is a network of physical object, you definitely need a connectivity. So that is a requirement to be part of an IoT. So if these things or objects are connected in a network, therefore, these objects are able to share, collect, and exchange data among themselves. Can you imagine how many billion of bytes per day we are basically wasting? Literally, we are wasting billions of bytes every day. So with this type of technology, we are now able to collect and exchange. By collecting this data, we can definitely apply analytics, which is very, very important in IoT. So a simple definition that will cover everything every time you talk about IoT. Because there are so many arguments, discussion regarding what is really IoT. So each one may have its standpoint, may have its own interpretation. But this particular statement here clearly clears our doubts that IoT is just simply a network of physical objects which are capable of collecting and exchanging data. So if we now understand the meaning of IoT, then where is IoT? Is it at home? Is it in my body? Where is it? So IoT is literally everywhere. Really? Some of you might ask. Indeed, it is even found in your watches. Okay? Majority of us now are shifting from traditional watches to smart watches, isn't it? Because smart watches is capable of measuring our heartbeat, our oxygen level, could determine how many steps have we done in a day that a traditional watch cannot do. And these watches can be connected to the internet as well and can be recorded and might have some software on it, right? Where else? It is now currently used in medical industry, particularly now that we are on the pandemic. So if you notice people coming to Oman, they're basically given watches, okay, for the monitoring. So those are examples of application in medical but utilizes the use of IoT. Where else? Smart homes, right? A lot of us now are definitely using this technology, but at the end, though it makes our life easy, people tend to become lazy, right? IoT makes our life easy, but also makes us lazy. It sounds like, right? So today, IoT is being used extensively to lessen, take note, to lessen the burden of humans. Really. They don't want us to do anything. They just simply want us to sit, right? We have the smart homes, smart businesses, smart city, smart university, or smart application, agriculture, even autonomous car. See, can you imagine how lazy people would become if the technology is always around us? That is always the consequences. Take note, in every advances that we have, there is always a fallback. Okay? In every advantages that we create, there is always a corresponding disadvantage. So at the end of the day, we should weigh which is important. So when we talk about IoT, definitely it has an infrastructure. It has an architecture. So what are the major components of an IoT? Of course, an IoT cannot be an IoT without the thing, right? Or the device itself. And since IoT is a network of physical devices, we need an interface, right? An interface that allows us to communicate. And this data taken from the thing can be stored. Okay? Storing a data can be an option. But for me, it would be very important that we store information. Why? Information, if analyzed, becomes knowledge. I don't know if you will agree with me. Information which are simply stored, if analyzed, would become knowledge. Why? Some of us, supervisors, managers, would definitely rely on this particular technology, data analytics, because it will give us feedback, which is very, very important, okay, of the current operation of any IoT technology that we are deploying. And for me, those data must be processed, okay, because those data will be very, very valuable later on. And definitely, if you have this application, you need an interface, user interface, so that our project becomes interactive. So this is the major components of IoT. So what is the relation of this thing to my topic this morning? So take note that LORA, which is a physical layer, which can be somewhere here, and the LoRaWAN, which is an example of a low power wide area network, will be dealing on these two layers. Okay, so the focus now will be on this. So if you notice later on that it's not just a similarity, it's almost identical, that the architecture here used in IoT is just the same as the architecture used in LORA. Now, why I choose this topic? Okay, number one, the popularity of LORA in majority of countries, particularly in Asia, or the adaptation of this technology is not that much yet. In India, it's around less than 20%. So meaning there are still challenges, right? So what are the challenges currently we have in the deployment of IoT? I know that we have around 41, 50 participants this morning. And I presume that more than half of you have already deployed an IoT project. Previous weeks, I have attended a research conference in India as well, where I noticed that when it comes to telecommunication, almost majority of the projects are in relation to IoT. And what have you noticed? While deploying your project using IoT, you always use the most common, the most common technology, which is cellular, isn't it? Because it is always in front of us. It is very convenient to use this type of technology because it is around us. We can just simply take it from a store. We can just simply access and pay for it. That's correct. And take note, I am not against cellular companies. I am not. But what I will be doing this morning is to give you an alternative. Okay? Or I call it an option in order to deploy your IoT project. Take note, IoT project is not only restricted to cellular. You can also do IoT project without paying to a cellular company. Okay? And for me, that is great. Particularly if it could last for several years. Now, what are the challenges? There is a big problem now with interoperability. We know that interoperability is a problem ever since IT have been introduced to us. One device will not work with other devices. That's really a problem. But currently, this problem is addressed by the alliance. We call it the LORA Alliance. So with LORA Alliance, interoperability is not an issue, which is good because you can just simply mix up devices from different vendors, isn't it? That would be great. Why? Because it will result to a lower cost. Okay? Then there are also problems with standards, okay? Particularly on the layers of IoT solution. So this problem can be addressed by LORA and LORA technology. So now, this is my topic for this morning. First, what is LORA? If you notice, I have asked you several questions already. This is my third question maybe. What is LORA? Okay. Is it a thing? Is it a device? Is it a network? Okay. So people might have different perspective. People might have different understanding. Or might be this is new to you. Right? So let's see. LORA is just simply a low-powered radio. I give emphasis on the low-powered. Since it is a radio technology, this belongs to a wireless network. Okay? So other than being low-powered, it is also capable of having long range. So it is a good combination. It's just coffee and milk. It's just like karak and milk, right? It's just like sambar and what is this color white, which I love eating basically, or dosa, right? It's just a perfect combination between these two. So LoRa communication is a technology which has been created, can you imagine, in 2009 by a French company, but only sell to Semtech, which has now the ownership of LoRa, which was introduced since 2012. So therefore, the technology is not new. It is around 10 years already. but unfortunately, only a few are currently maximizing the use. I hope that there are so many educators here this morning because you have a big role in helping this particular technology to be propagated, to be shared with other enthusiasts like us. So LoRa is a wireless technology that both offers long range and low power transmission. Okay? Having a secure data transmission between machine to machine and IoT applications, right? So LoRa can be used to what? Connect sensors, gateways, machines, devices, people, animal, and a lot more, which is wirelessly connected to the cloud. Later part of my presentation, I will give you some few use cases currently in India, and you will be surprised that those projects are not complicated. Very, very simple project, yet very helpful to the citizen and to the country as well. So what is LoRa? Okay. So LoRa utilizes wireless modulation. To be specific, we are using the chirp modulation. Okay. LoRa, okay, is not LoRaWAN. Take note, LoRa is different from LoRaWAN. LoRa is a physical layer, okay, which is used for long-range communication. LoRa have lower bandwidth. LoRa will definitely provide you with low battery usage. Can you imagine deploying a project in a remote area where electrical supply is not available, where only battery will work, that lasts for even up to 10 years? Have you deployed projects like this? Right? Can you imagine how it will be useful? Because majority of our project are either using the AC line or might be using the renewable energy of solar. But here, a simple 1.5 or 3 volt battery would allow your device to work for several years. And the good thing about LoRa, because it's a license-free band, an ISM used for industrial, scientific, okay, which is used all over the world. India is basically using this particular spectrum, the 915 megahertz. 438 is used in most likely in US, okay? 868 is in Europe, and 915 is in Asia country, okay? Asia region. So this is regulated when it comes to power and duty cycle. And the best thing about LoRa, if you are an educator or a telecom engineer, you are very familiar with what we call as link budget. And you know how important link budget is, particularly for wireless communication, right? Can you imagine 156? Cellular is only around 130. Can you imagine the difference between the two technology? Okay, so on my right, these are just examples of a LoRa. This is made by React. This is not a sponsored. I just took this from their website just for the purpose of showing you an example. But this type of LoRa already have a built-in microcontroller, which is very easy to use. Okay, some LoRa doesn't have microcontroller, but this type has. Okay, so when we talk about LP1, or simply known as the low power wide area network, this is a type of wireless communication which is designed for sending small data packages over what? Over a long distance that only operates on battery. Okay, so this is a type of wide area network that will satisfy this requirement, capable of sending small data packages over long distances and operating on battery. And LoRaWAN is not the only. Take note, LoRaWAN and LoRa is not the only technology available. We also have numbers of competing technologies. We have the NB-IoT, which is the flagship of cellular, the SIGFAX, the LORA, and among others. Okay, so there are competing technologies. I'm not saying that this is the only, it's not. There are several. And I would like to highlight LORA as compared to other technology. Okay, so let us compare LORA when it comes to data rate and range as compared to other technology. When you talk about data rate, there is no argument that cellular communication would definitely provide you with the data rate that you wish as well as the bandwidth. We don't have any issue with that. And I'm very happy that they could, right? But take note that every bandwidth and high data rate that they provide, it always come with a cost. There is no such thing as free, right? So this is where I am getting my inspiration, cost. So when it comes to data rate, even the short range wireless communication are even better than LP1. Really, they are better in terms of data rate. The most near application between LoRa is, I guess, the Zigbee. Zigbee can compete with LoRa, but the only problem with Zigbee is the range, okay? Unlike LoRa, SIGFAX, and IoT, or NB-IoT, data rate is very low. But, again, range is very long. That is what I'm saying earlier. In every advantage you get, there will always be a corresponding disadvantage. It's always a give and take. It's always a trade-off, right? You cannot have everything. If you want this, you have to give up something. In this case, LP1 give up the data rate in replace with the range as well as with the bandwidth. It follows. A smaller bandwidth would definitely provide you with a slower data rate. But you know what? It will provide you with an advantage. Let me ask you again this question. Compare your IoT project before that you have deployed earlier. Do you need big data packages? Those projects before, does it require big data packages? Most likely, your IoT projects are used just to switch on and off certain devices. And that would not require big data packages, I presume, right? So why spend too much on something which is unnecessary? That's my point basically. At the end of the day, we will try to see that deploying projects in LoRa could definitely save you a lot of money. So every time we talk about link budget is just the accumulation of gains and loss, okay? Particularly in a wireless communication. Signal, as they travel, basically they get attenuated, or signal becomes weak as they move from point A to point B. So in this case, since it is regulated, the allowable amount of power is only limited to around 14 dBm. So before transmission, definitely, our signal from the transmitter would have some few losses due to its connectors, but it will gain a bit before transmission. And as our signal propagates in free space, notice that a drop, an exponential drop, particularly on its power. We all know, telecom engineers, if we want our signal to travel long distances, increase the power, right? Increase its power. But how are you able to increase your power if you are operating with battery, right? So increasing the power in LoRa will not help us reach destination. But you know what? What makes LoRa reach farther destination is the reduce in bandwidth, right? We learned that before. There are two ways on how our data could reach far distances. It's either increase the power or reduce your bandwidth. And in LoRa, we choose this one. because we want to maximize the power. And take note, power and bandwidth always come again for the second time, certain costs. Okay? So there's always a trade-off. So signal, as they reach the receiver side, they are attenuated already. Very small amount of power could reach the receiver. That is why the receiver should and must have a good sensitivity. We all know that sensitivity is very important. The ability of your receiver to pick up weak signal. And notice, in free space, we have thousands of signals, RF signal passing by. But how your receiver could receive those low power signal is the ability of a receiver. So link budget plays an important role here. So with this given formula, I would like to give some few emphasis on the correlation. Increasing the distance, okay, especially squaring the distance, would definitely increase your free space path loss. And it is directly proportional. The farther it is, the more loss the signal will experience. And worse is, it is a function of the square, right? So as it goes along, the free space loss will definitely increase, as well as operating at higher frequency. Operating at higher frequency is good if you want a higher data rate and a wider bandwidth, which is currently used in 5G. Yeah, I don't have any issue with that. It's good. But take note, it will demand a lot of power as well. So here, in order to reduce free space path loss, we should limit, okay, the bandwidth of our signal. So notice that doubling the distance would create around 6 dB of path loss. And it will provide a difference in free space path loss between two spectrum from 868 to 2.9 gigahertz, almost around 9 dB of free space path loss. So can you imagine that? That loss will be great based on the distance and on the frequency. So sensitivity can be affected by thermal noise, of course. And notice that thermal noise is also directly proportional to your bandwidth. So the wider the bandwidth you have, definitely would create a more thermal noise at the receiver side. So given that idea, given this formula here in sensitivity, we know that your bandwidth, your signal to noise ratio, and your noise figure have a direct effect. Okay, let me give you a simple calculation of how link budget is done. Okay, so assuming that we have a transmitter power of 14 dBm and let's say a bandwidth of around 125 kilohertz, then an SNR of 20 using the spread factor of 12, a noise figure of 6 dB. Noise figure, by the way, gives us an idea how your signal deteriorate. So the higher it is, okay, the more loss that your signal will accumulate. Then applying those value and substituting, notice that the sensitivity of your receiver is around minus 137 dBm, which is good. Applying it on your link budget, can you imagine? A link budget of 151 dB theoretically could go as far as 800 kilometer. Wow. But this is theoretical, right? This is a theoretical value. Let's be honest with this. So, what are the things that might affect your signal in free space to make it more realistic? So, there are three factors: reflection, diffraction, and obstruction. We learned that already in our BTech, right? That reflection might create multiple path fading, and it will introduce what we call as ISI, or inter-symbol interference. Diffraction and obstruction also will reduce signal strength. That is why 5G have so much challenges, okay, currently, because it might provide us with a higher data rate, but distance-wise, penetration-wise, that's a big issue really. How many antennas you need, right? How many repeaters you need in order this technology to work, right? So trade-off again. So LORA basically work on the CSS, or we call it the chirp spread spectrum, okay, that uses a wideband linear modulated chirp. So LORA signals are basically narrow, right? They are narrow band signal. So if it's a narrow band signal, we know that in FDM or in FDMA, it can be easily be interfered. It can be easily captured. So therefore, it might be difficult for us to secure our data. So a type of spread spectrum is used here. We call it the chirp spread spectrum, wherein that narrow band here is integrated to a higher data rate signal, which is even below noise level. Just like what, it's not the same, but it's just like almost the idea of CDMA, where the narrow band is basically integrated to a higher data rate signal, wider bandwidth, to look like a noise. We call it the pseudo noise, right? So people might not easily intercept the signal if it is spread and it is basically even approaching the value of your noise level. So LoRa demodulate below noise floor. It has better sensitivity because your the power density is spread across. It's more robust. Okay, it could withstand interference, noise, and definitely jamming. It could tolerate frequency offset, and it has a simultaneous occupation of a single channel. There are several key properties of a LoRa modulation. LoRa modulations would definitely offer a high robustness, multipath and fading resistant, and long-range capability. The word low power and long range will be repeatedly included every topic that we have. So for a fixed output power and throughput, the link budget of LoRa would definitely exceeds that of a conventional frequency shift keying. When including robustness to interference and fading, this improvement in the link budget could basically, imagine, translate into enhancement in range 4 times. Okay, 4 times far from the original capability of a conventional FSK. Now, let us try to compare your data rate and spread factors. So spread factors enables the exchange of data against receiver sensitivity. So notice here that your spread factor of 6 to 7 would basically have a value of its signal to noise ratio in dB, as well as its correlation in terms of its bandwidth and its sensitivity. So if you notice here that as your bandwidth increases and as your spreading factor increases as well, notice that your sensitivity, notice your sensitivity here also improves, right? Particularly in this particular bandwidth. But if you compare this to a lower bandwidth, definitely your sensitivity is far more better. So in terms of data rate, wider bandwidth basically would have values of around 37,500 in bits per second. So these are the correlations of bandwidth, data rate, and your sensitivity, as well as your spreading factor, and your signal to noise ratio. So there are some few variation here, okay, that you can experiment based on the need of your project. So notice here that when your data rate is very high, what would happen basically? It will be concentrated only on a certain portion, covering a smaller distance, right? It will only cover a smaller distance. But spreading it allows us to increase our signal capability to reach far destination. So these are the things that you need to consider, because when you design, not all design are created equal. When we design, we want to create something and customize according to the need. One project may not necessarily be the same to the other project, okay? Because your variables and your parameters might differ. So every time we do and deploy IoT project, we are most likely customizing the project based on the need. Now, LoRa was the physical device. It's a layer 1 device. On the other hand, when we talk about LoRaWAN, we talk about the network itself, the ability of those devices to be connected to a wider area network. So LoRaWAN is a low power wide area networking protocol. Remember, it's a protocol, right? In internet, we have the TCP/IP. Here we have a different protocol for LoRaWAN, which is developed by LoRa Alliance, that is wirelessly connect your device in a battery operated things to the internet, may it be national, regional, or even global requirements. And the good thing about LoRa, because it can be integrated in a cellular network, I will explain it later on. Okay, it is not restricted, but LoRa in general is a non-cellular technology. Again, let me put this one into perspective and to make it clear. LoRa by itself is a non-cellular technology, but LoRa together with LoRaWAN can be integrated to the backbone of a cellular network. So some of you might be confused. Your topic is to introduce LoRaWAN, yet you are talking about integration to a cellular network. Yes, it can be hybrid, but still costs can be reduced, right? Unlike deploying projects purely on a cellular level. If you deploy your IoT project purely cellular, that would be costly as compared to LoRa plus the cellular. Okay, let me explain that later on as I give examples. So IoT communications can be seen the importance in terms of battery life, in terms of range. I guess you have already deployed some few projects wherein you have a lot of problems here, particularly for remote area. In Oman, we have a lot of deserts, okay? Remote desert that there is no even electricity, no source of water, no source of cellular network. So what will you do on those areas? Especially if you are working in an oil and gas company. Most likely they are using satellite. And satellite communication is not a joke, right? It's a bit expensive. So how are you able to deploy project using battery only that could last even up to 5 years? Have you done a project which is capable of working for 5 years only with battery? Maybe or maybe not, right? So notice here why cellular basically is not a choice when it comes to battery life, because in cellular, you are constantly communicating to the network. We know that. Every few milliseconds, we need to update our location, right? as we move along, as we have handoff from one base station to another base station, we always need to synchronize our information and device to the base station. And what does it mean? That means it is a continuous power use, isn't it? Because you are updating your location. And that is one of the problem of cellular technology in application that would only require battery. I'm not saying it's a bad solution. It is not the best option, particularly if you are working on a project that only depends on a battery supply, right? So what are the best project? Definitely these things, right? LORAWAN, NB-IoT, LT-CAT-M, and so on and so forth. Notice, NB-IoT class is almost same as LORAWAN, right? But again, NB-IoT is a technology which is powered by a cellular network. So here, you will notice that you have both advantages of having a good battery life and a good range in terms of technology. Now, let us demonstrate some few relationship among the existing network. Let's talk about local area network. Local area network would definitely provide you a good bandwidth, a good data rate. And it has an established standard. And it can be used indoor and outdoor provided the distance is adequate. But what is the problem of local area network? Battery life, provisions, and most of all, see, the word cost have been mentioned several times, right? How about cellular? Very good existing coverage. We know that. It's not new to us. Really, indeed, that is the advantage of a cellular network because it has a good existing coverage and it can provide you with the data rate that you need, provided you pay for it. But again, same with local area network, battery lifetime is a no-no. And definitely owning a SIM card, a module, would require you a cost. And versus it is a closed system. So what makes LoRa a better option? Again, I'm not saying that it's the best, but it is an alternative. Why? Because it could consume less amount of power. It would only require you a small amount of money. Okay? Sensor positioning is easy. But of course, even LoRa has its own disadvantages. We know that. In every advantages we get, it also have its shortcoming. It is just an emerging standard. Yes, it is. But there are so many companies now working on it. And definitely it will have the lowest data rate. But again, my question is, does your project requires higher data rate? Is turning on and off a device would require you a higher data rate? It's up to you. Because sometimes in most of our project, we overkill the project. Overkill means our capability is so much wherein the application is very simple. Right? It's just like putting 5 jacket on a simple rainy day. Why you need 5 jacket on a simple rainy day? It's not even snowing at this point. So I hope you get the point. So even it will give you a lot of advantages, but definitely it will also give you some few shortcomings. That is why at the end, you will decide. It's you who will determine your need. Okay? Now, this is the LoRaWAN architecture. If you notice, it's almost the same as what I have discussed earlier. It's just that some terminologies are used. So when we talk about devices here, we call it end nodes. And those end nodes have an integrated sensors and LoRa on it. Okay? LoRaWAN simply transmit, okay, to the nearest gateways. So I have one participant last 2 weeks ago. He asked if the backbone of LoRa can be independently be separated from a cellular? Yes, of course. Because in LORA and LORAWAN, we also have operators. LORAWAN network can be both public and private as well. But also, we do not restrict LoRaWAN to be an independent network. It can be integrated also to the existing network, which is a cellular network. That's why it can be hybrid based on the need, okay? But if you want to communicate between LoRa to LoRa, it's fine because LoRa is built for non-cellular application, right? So end nodes will transmit and consolidate all the information and will send the signal wirelessly to your gateways. And of course, this data must be forwarded. Gateways will not store those information you send. It must be forwarded. Okay, and it can be saved in a database in the server itself. So cellular have its own server. And take note, LoRaWAN also have different server. To name a few, we have the Things Network, right? We have Things Peak. We have the Things Industry. We have the Things Park, and so on and so forth. So there are also several servers that could help you store your information and do some analytics. And of course, those information must have an interface, right? That requires an application. So several protocols are used here. The most common is the MQTT and the AMQP. So this is just a simple presentation of a LoRaWAN architecture. Now, some of you might ask, what makes LoRaWAN a better option when we talk about battery-powered devices? Why it is a good alternative when we talk about range? Okay, so let me show you some few examples of LoRaWAN device based on their classes. Okay, they are also classified in 3 classes, A, B, and C. And it is plotted between latency and battery lifetime. Latency means delay, right? Now, if you use a class A LoRaWAN device, these are battery-powered sensors, okay? Your sensors are just simply battery-powered. It is very efficient in terms of energy use. I will explain later on my next slide. And it is supported by all devices. Downlink available only after sensor transmit. So in terms of power supply, definitely class A would be definitely the best choice. Okay? It will be your best choice, but latency here is a bit higher. Now, if you choose class B, in class B, aside from the sensors, you integrate actuators already. Meaning your device could respond to a command, right? It is still energy efficient with latency controlled by your downlink. It has a slotted communication and it is synchronized with the beacon. So class B is somewhere between A and C, particularly in the battery life as well as on its latency. Class C, on the other hand, provides more actuators and it continuously listen to the network. So now latency here is used for the downlink communication. And also, it has a powered actuators. So my next slide will show you the application of different classes. And some of you might be surprised that these are just simply simple application that you might have done earlier in some of your project supervision or in some of your project deployment. Let's talk about class A. I've seen this project in Silvam College. That was 2 or 3 years ago. Yeah, 2 years ago when they invited me for an international conference. I like that idea from one student, from a student, yes. It is a smart bin, but at that time, they are using the GSM module. And we all know that the GSM module belongs to a cellular network. So can you imagine if you deploy your project all over the city? How many module of GSM you need? And how much you have to pay every month to maintain those modules, right? But in this case, a smart bin that utilizes LoRa devices would only allow you to report for a few times a day. Why you need few times a day? Smart bins are not full every time. It start empty, then it will gradually increase. So do you need continuous data? No. You only set some levels. Let's say after reaching this level, a signal or a data will be forwarded to the server. So it will not consume a lot of power. After sending, your sensor sleep, right? That is what, and that is why you are able to save battery. No planned actuation. There's no actuator, so no need to power anything other than your sensor. So therefore, it only uses extremely low amount of energy. On the other hand, such as in this particular project, we call it the irrigation system, which is also used currently in India. It reports moisture a few times per day, right? Moisture will not change every minute. It will take time. Let's say every 4 hours, from sun dry to dawn to evening to morning, there is a time interval. So reporting is not frequent. That is why Class B could save you amount of power. But the only thing about this, because you can basically send a command that would turn on and off a valve, right? Which is your actuator, which can be used for some minutes, okay? And may have some few latency on it. So in terms of energy consumption, compared to C, it is still low, right? And on the other hand, using a Class C LoRa, one application is smart lighting. And you know what? Around 3 or 7 major cities in India have been utilizing LoRaWAN for smart lighting. Okay? So maintenance and index in a few times per day, but the only thing is that it is constantly listening to the network. So ping has been sent all throughout. Therefore, in terms of power consumption, C will have the least, okay? It will consume a lot of power compared to A and B. So what have you noticed in this type of project? Smart bins, irrigation, smart lighting. These are very, very simple projects that will not require you so much expenses as compared to the traditional way of deploying through the cellular network. So LoRaWAN network will provide you with some feature. Long range, without no doubt, it could go as far as 100 kilometer, right? Greater than cellular in terms of range. It can be used indoor or outdoor, and it used the star of star topology. Maximum lifetime. Low power consumption. Can you imagine? Project that could even last for 10 years. Wow. Especially if you are deploying projects remotely. 10 times greater than the cellular. I'm so sorry if there are some people working in cellular company. I don't have any intention to make cellular look bad. No, cellular is good, but I'm giving her option for those who want to do project which would require only low cost. Okay, it will have a private and public network. Obviously, it will have increase in capacity and multi-tenant. And the good thing about this, it has a minimal infrastructure, low cost end node, and open softwares. Okay? So, how do we integrate LoRa in our project? Let me give you some few illustration. Let's say you are just a simple farmer. Let's say you live here. Okay? This is your house. And this is your small farm, right? And since you are a technology guy, you need to know all the information with regards to the moisture, temperature, and so on and so forth, okay, in your farm. So if your farm and your house is less than 100 meters, you can use Wi-Fi, right? Wi-Fi can be an option. Why not? right? It's an existing technology. Good. Or if this is 1 kilometer away from home, Wi-Fi is not accessible anymore. So the best thing you do is to use the GSM. That is the first step you need, right? That is the usual choice without a doubt. If distance exceeds 100, GSM module is the best solution. In fact, it is, right? But again, it will incur costs you need to pay for the subscription. So why not use LORA? Okay, this is where LORA is useful. Why not use LORA? LORA could even go as far as several kilometers. It could be even around 5 kilometers away from home, especially if you have a good line of sight. It will reach up to this distance. And you can monitor everything from your farm. All you need to do is to put sensors here strategically, add some sensors. You need microcontroller, you need a small battery, and connect it to your LORA device. Then set up here, you put another LORA, then that's it. You can now start communicating from your farm to your house without paying anything to a cellular network. Problem solved, isn't it? And these LORA are very cheap. So this is why I said this is an important information. I'm not saying that all of us will use LORA. It's not. At least we have a choice, okay? At least we have an alternative, okay? That is better than rather having none. So now, what are those some few modules that we can use? There are so many manufacturer really. We have from Rayax, we have from Microchip, and here we have from AI Thinker. So these are only few of the vendors that we have that could provide. Notice that most of the LoRa now are having a built-in microcontroller. Okay? Or by the way, this LoRa can be integrated with other devices such as Arduino. It can be integrated together with your Raspberry Pi. It can be done. Now, how do we connect LoRa? LoRa can be connected between two LoRa, okay? A point-to-point LoRa. That's fine. Or you can have a multi-point. In this example, it is a broadcast LoRa. It could send to several nodes, right? It can accommodate several LoRa around it. You can basically create a LoRa network out of it. So this is just a simple integration of LoRa sensors of LoRa modules in your IoT projects. So what makes LoRa a wide area network? So LoRa plus wide area network is called the LoRaWAN. Take note, your LoRa are connected to your end nodes. So these are physical layer. LoRaWAN, on the other hand, is the layer 2, which is your protocol. So what make LoRaWAN or LoRaWAN gateway connected to the network? In my example here, I have made a hybrid type of example, which can be common to some. So you have a LoRa network here. When you said LoRa network, it is composed of different LoRa devices, okay, which are connected to different LoRa sensors, right? So this LoRa can send information to your gateway. So what is inside your gateway? Inside your gateway is also another LoRa device or LoRa chip that accepts all the information coming from your LoRa network. So since we want to connect to the internet, you can basically integrate an internet chip here. In this case, we put the ESP8266, right? That is a Wi-Fi module in order for us to connect to the internet. So this is just a simple DIY, okay, connection. If you notice here, the middle here is the parallel connection between the LoRa chip and the internet chip. So gateway allows us to connect to the internet. That's the good thing, because you can even control your projects globally. That means from even other regions, if we are able to connect to the internet. And at this point, we can definitely use the cellular, or we can opt for the uh, public network for LORA Alliance. There are several choices. But in this case, what we have done is just simply integrate it using a Wi-Fi module. And the Wi-Fi will definitely connect to the internet. So several servers can be used. ThinkSpeak, okay, the Things Network, and so on and so forth. So this gateway allow us to communicate to other network within a wide area network. Okay, so definitely you need an interface or a server to store and analyze and display your information. Okay, so there are different types of LoRa, by the way, or LoRa gateways. These are gateways which is positioned indoor or positioned outdoor. LoRa can also have different configuration. LoRa can have single channel, or LoRa can have multi-channel that could accommodate multi nodes. Okay, so what are those examples? So this is a LoRa gateway which is used indoor. It looks like our routers, right? Or access point. And these are your outdoor LoRa. Your outdoor LoRa can be private if you want to use it alone, or you can share it and make it public so that other LoRa users can use your LoRa gateway as one of their means of communication. So those are just examples of both indoor and outdoor, or single or multi-channels LoRaWAN. So now, in order for you to have more knowledge on LoRa, I would suggest to visit the LoRaWAN or the LoRa Alliance website. So LoRa Alliance is a fast-growing technology. Okay, it's a non-profit association with more than 500 members, which are committed, okay, to enable large-scale deployment of low-power IoT projects. So in this case, given this number of companies, this is where collaboration will be important. There are so many brilliant scientists or enthusiasts in India that have good idea. But will you agree with me that your idea cannot be deployed because you don't have enough resources? Am I right? Right? Idea cannot be materialized without resources. But with this group of companies and alliances who know, you can collaborate with them. Okay? So these are just some few members of the LoRa Alliance. We have the Amazons, right? We have the Arduino, we have the Cisco, by the way, we have the Intel, we have the Chevron. Okay, these are big companies. But don't worry, there are also big companies in India. This was the membership in India from 2016 to 2019. Notice only a few of them: Tech Mahindra, Tata Communication, Volansys, CyberEye. And what makes me sad here is that only a few institutions are here. When I said institution, that refers to universities and colleges. It is not a bit popular. Why? Because majority of us becomes very convenient in using the cellular technology, right? It is a comfort zone for us. In any IoT, go cellular. That's the only thing. But you will be surprised that in 2020 and 2021, the number of institutions have increased. And we are so happy because, you know what, institution could basically propagate the information through our student, right? Through encouraging them to test and to check the alternative when it comes to deployment of IoT. So in this case, you will notice that India is only utilizing less than 20% of LoRa. within the entire region. Does it sound bad? No, this is sound opportunities. This sounds good. Why? Because there is a lot to explore and only a few are still using. Take note, in anything, if you are pioneer on it, you will basically gain more than rather copying someone's doings, right? So India utilizing 20 less than 20% is not a good news. It's not a bad news, rather. It's an opportunity. So what are those opportunities that I'm talking? So opportunity 4, there are more than 50 maybe participants, let me see, 87 participants who are listening to me currently. And all of you doesn't have the same skill, right? Some of you are system integrators. So what are the role of a system integrator in a LoRaWAN network? Okay, that allows us to gain these opportunities. So you can stitch a network with your own application and analytics, meaning offer unique solution. And without a doubt, I totally agree that when it comes to IT, India is one of the best, if not the best, right? We should agree on this. There's no doubt. Who is the CEO of Google, right? And who are those people big in Silicon Valley? We know that. That is why I said it's an opportunity. So you can also offer NAS model in building and owning a LoRaWAN network, or praise or pure SI role of a network planning and implementation. Then go ahead. If you think you have the skill, then go ahead. Now, if you are good on developing devices, come on, collaborate with other companies. Companies have enough resources, meaning they can provide funds. Your idea plus their resources can be a good start, right? So look for someone who will like and love your idea. So do not be discouraged. No, I'm poor. I doesn't have enough resources. I would stop doing this. No, take that idea of yours and find some companies to collaborate. And I know that there are a lot of companies who are more than willing, okay, to help you. So you can augment their devices portfolio. Can you imagine? You can create your own LoRa module if you want. Create your own customized devices with specific application. Tie up, see, collaborate with other overseas manufacturers. It's not impossible. All you have to do is to tell them your idea and let them listen. If they like it, then you can do some startups or analytics. Analytics is very important in IoT. Why? Because a lot of information are wasted. Billions of bytes and bits are wasted. But with analytics, this information becomes knowledge, right? So analytics, create your own customer experience with analytics. I don't know if you have experienced this. Let's talk about, I don't know if you're using Facebook in India. Using Facebook, sometimes you will notice the ads. Ads allows you to see things you like, right? You will notice that in Facebook, that all the ads that is flashing in front of you are the things you like. Why? Because you visit some websites, right? And those websites are stored and analyzed. Therefore, these people in Facebook or in any app will know your characteristic and will feed you of things you like. What will happen? You will definitely basically later on buy their products. We call it analytics. And if you have that skill, go ahead. You don't need to create your own device. You don't need to be a system integrator. Come up with your own analytics. If you are good in data science, go ahead. Or you can be a service provider. Launch a greenfield network, offer various models for sensors, or offer a custom business to business or business to commercial solution. So these are opportunities. And I do hope that our participant this morning could basically identify themselves among these different opportunities. Okay? Now, what is currently the situation of India? In India, there are around 90 public operators, okay, who are deploying LoRa. That is fine. 6% of them, okay, are private operators. So majority are public, which is good. And this is the sad part, because only 1% deployment in universities or colleges. So a bit limited, right? This is before 2020. This is 2019 data. But see here, in 2020 to 2021, see how many companies in India have joined the LORA Alliance. In the institution itself, from 1 to several members, right? In utilities, there are so many. Connectivity, chips and modules. Excuse me. Before, only a few of them. Now, there are so many opportunities that comes to their way. See, system integrator, such as the census, data projects, and so on and so forth. So I guess you have now the idea of those members, companies, utilities, okay, or even certifications that you might avail in using LORA. Okay? So these are just comparison of the utilization. The only thing that will compete with LORA is the NB-IoT, without a doubt. Because NB-IoT is cellular, right? Of course, they have good coverage. But notice here, the projection until 2023 that LORA will be as good as NB-IoT. Can you imagine? That's good news already. We can compete with them. But our advantage here is cost. Okay? So what are some of the use cases? So there are several use cases. But one of the most popular thing now in India is this. Water and gas metering. We also have smart energy. And the other one is for employee safety. Okay? Employee safety is also one of the popular application in India. Okay. So let me start by showing you with some applications. So this application is a smart lighting that can be integrated within a community or might be within the entire city. And this is what you have in India currently. There are 3 cities in India now who have deployed around 1,500,000 LED lights. What are the features of this project? It is remotely monitored. They are able to turn on and off and even dim the light. They will have an alert if lights are damaged already. Identify theft. They will know if someone will take the light from the street, and so on and so forth. Can you imagine? Can you imagine how much savings have resulted to this project? 15% savings in energy. Wow. That translates to a big amount of money and to big amount of less carbon footprint, okay, that we have emitted to the environment. It's a very good investment already. 15% savings in energy. They reduce the amount of number of light being stolen by around 28%, right? Can you imagine street light being stolen? But this device is capable of detecting. So they have saved around 28%. So as a result, saving energy and saving the cost would definitely lower your capital expenditure, which is very good for the local government because the saving can translate to other services, right? So this is one of the use case which is now being deployed in 3 cities in India. Okay, what else? Employee health and safety. This project have utilized 75,000 workers. They are being tracked in terms of their location daily. There are alarms, okay? Attendance can be monitored. Heart rate, fall detection is there, right? Normally, based on their statistics, there are around 278 million of accidents and fatalities each year. Can you imagine if your family member is one of the 2.78 million? It's not good, right? But monitoring them would definitely reduce, right? I'm not saying by integrating this project, it will eliminate work-related fatalities or injury. It will not. But it will definitely and significantly reduce those related fatalities. Also, we could avoid injuries by allowing us to track our employees. We will know where they are located because some employees might go on areas that they are restricted. But by doing such, we could basically save a lot of money in terms of insurance given to the employees. So around $90 billion of savings. Wow, it will translate to how many billions of rupees, right? And the best thing is that safety have improved. Can you imagine? 50% of incident due to overfall or over extortion and fall are reduced on this number would definitely saves lives, right? So come to think of it, these are not difficult projects. This one, we have done this project also in oil and gas here in Oman. So it is just a simple tracker used within the company. And the last use case that I have prepared, although there are some which is used in utilities. They can be used in water, gas, or electricity utilities. So some features because you can read fast without manual intervention, meaning less people will be involved. So less error will be accumulated. It improves your manpower, efficient tracking of consumption. Guys, this is very important. Efficient tracking of consumption. Normally, how much you pay in a month for your water consumption, for example, 5,000 Indian rupees, maybe. Is that enough for a monthly water bill? Maybe, right? So if you are consuming 5,000 Indian rupees per month, the company will know if you exceed, right? Just like what happened to me. I will share to you my experience around 6 months ago. My monthly bill for my water, monthly, reaches 50,000 INR. I don't have swimming pool at home. But why is it I have to pay this much for 1 month of water consumption? We found out that there is a leak on the pipe, meaning my water is leaking. If there is only a system that tracks my consumption, maybe after reaching 5,000, they should have warned me already. You are exceeding your normal consumption. So I will be aware, then I will investigate. But since there is no project in place, I have to pay the consequences. Can you imagine? This is already 1/4 of my monthly salary. So I have to pay this much for a monthly bill and I don't have a choice, right? But with this simple project, it will help the consumer and it will help the company a lot. Okay, so these are just simply some of the use cases which I have identified in India. And there are still a lot, especially in agriculture. Okay, so if you have any questions or anything you want to ask, feel free to ask during the discussion. So once again, thank you so much, guys, for being with me. And may God bless us all. Thank you so much.
Hello, sir.
Yes.
That we move for a query, sir.
Hello, sir.
Yes, sir. Yes, sir. I'm here.
Let me move for queries, sir.
Again, sir, I cannot hear you clearly.
Let me move for queries, sir. Participants' queries.
Yeah, we could answer queries now.
Okay, sir. Dear participants, is there any queries? Ask with our resource person by unmuting yourself, or you may put your questions in the chat box also. Sir, there is one question in chat box.
Yes, sir. Let me check.
Where can we buy these models in India?
Again, sir. Where can we buy this? Okay. In India, I'm not sure, but in Amazon or in AliExpress, you can purchase these devices. But specifically in India, I'm not yet sure. I'm so sorry I was not able to check the if there are some distributor in India. But if I could find some distributor, I will be glad to share it with you. Just send me your email. Mr. I guess this is Girish Gupta. Sir, if you want, I'll just post my email here. Then we could communicate. If you want to, I could even give you some link to start with your project. If you want a DIY project, I could share some information with you. So, Sir Girish, I have shared my email address. Okay, I hope that we could communicate and share some few knowledge on LORA. Okay.
Okay, sir. Let me wind the session, sir.
Yes, sir.
Hello.
Is there any other question?
I think there is no more queries, sir.
Okay. Thank you so much. Thank you so much.
Okay, let me wind the session, sir.
Yes, sir.
Hello, sir.
Yes, sir. Yes, sir.
Let me wind the session, sir.
Not yet.
Okay, sir.
Yeah.
Feeling gratitude and not expressing. It's like wrapping a present and not giving it. In this way, I would like to thank our resource person, Dr. Jonathan M. Casino, Quality Assurance Head, Triple Section, University of Technology, Muscat. Thank you, sir. Thank you for your presence, sir.
You're welcome, sir. And good luck to all our participants. Thank you so much.
Dear participants, the day 5 session to attend and feedback link is posted in the chat box. While filling the form, please select your respective ID, which is already mailed to you. Once again, verify it and fill the form.